Hello, everyone. Let's talk about a key concept in microeconomics that deals with how sensitive consumers are to changes in price. This is called price elasticity of demand. Here's the formula for calculating price elasticity of demand, symbolized here as an E with a subscript D. It's defined as a ratio of the percent change in quantity demanded divided by the percent change in price, which produces an elasticity ratio that varies above and below 1.0. Elasticity ratios above 1.0 indicate that demand is quite sensitive to price changes, or in economic parlance, elastic. Conversely, ratios below 1.0 indicate that demand is relatively insensitive to price changes, or inelastic. A ratio of 1.0 is neither elastic or inelastic and is called unit elasticity. Let's start out with a simple demand curve. We need to remind ourselves that demand curves based on real data are likely to be much more curvy and not a straight line. The price per unit is shown on the vertical axis, and the quantity demanded in thousands is shown on the horizontal axis. Suppose we lower the price per unit from $9 to $8, as shown by the gray triangle. This is a $1 reduction in price. Similarly, we could lower a price from $2 to $1, also a $1 reduction. In absolute terms, these are the same reduction. But we have to remind ourselves of something, namely, the formula requires that we use percentages and not absolute changes. So let's recalculate these price reductions on a percentage basis. A price reduction from $9 to $8 turns out to be an 11.1% reduction using the standard formula for calculating percent change. Doing the same thing with the $2 to $1 case produces a very different result, a 50% change in price. So going from $2 to $1 is a much larger percent reduction compared to $9 to $8, or 11.1% compared to 50%. The formula also requires that the quantity demanded be expressed in percentage terms. So let's do that. In the $9 to $8 case, the units demanded went from 1,000 to 2,000. This represents a 100% increase in demand. Moving to the reduction from the $2 to $1 case, demand went from 8,000 to 9,000. But this is only a 12.5 increase in demand. In the first case, a 100% increase is seen, and in the second case, a 12.5% increase is seen. So what we have here is an 11% reduction is associated with a 100% increase in demand, and a 50% reduction is only associated with a 12.5% increase in demand. So let's do some calculations here of elasticity ratios. Let's focus on case 1, the 11.1% price reduction and 100% increase in demand. Plugging it into the formula, we get an elasticity ratio of 9.0. An elasticity ratio of 9.0 means that customers are very sensitive to price changes. So what are the implications of this very large elasticity ratio? Well, as a seller, you should consider a price reduction, since consumers will react strongly and greatly increase their units purchased. However, beware of raising prices. Demand will drop dramatically, and the price increase will cause a lowering of demand, and the seller will probably lose money overall. Let's look at the second case, case 2. Here we had a 50% decrease in price, but only a 12.5% increase in demand. By the formula, we have an elasticity ratio of 0.25, well below 1.0, so we're going to call this ratio inelastic. It means that consumers will be relatively insensitive to price changes. If the seller reduces price, they'll get little response from the consumers and will likely just simply lose money. However, raising prices on insensitive consumers will likely lead to an increase in total revenue because they're not that sensitive to the price increase. Now you see why elasticity ratios would be very important to sellers' pricing strategy.